Greetings, class. This is Dr. York-Hammons, and today we're going to look at Chapter 6, Section 3, Confidence Intervals for Population Proportions. Now, you'll remember in Sections 1 and 2, we were finding confidence intervals for the population mean. So today we're looking at a population proportion, which is a little bit, it's a different parameter than before. And so we will use different types of statistics to find that. So the definition of a point estimate for P, the population proportion, so it's important to note that the little small p in this case is population proportion of successes, is given by the proportion of successes in a sample and is denoted by P hat equal x over n, where x is the number of successes in the sample and n is the sample size. So x is the number of successes and n is the sample size. I'd like to look at a few examples from the exercises for Chapter 6, Section 3 that begin on page 325 in your text. So let's look at number 3. It says, in a survey of 1,002 U.S. adults, 662 think that humans have had a mostly negative impact on the environment over the last 10 years. We want to find the point estimate for the population proportion. To do that, we need to find P hat. Now, P hat is the number of successes, that's your 662, out of your sample size, which was the full sample was 1,002. So if I have my calculator, I take 662 divided by 1,002, and I get 0.66067, or approximately 0.66, as the proportion. That is P hat, and that is an estimate for the population proportion P. So once again, P hat is 0.66 because it's based on my sample, and it is an estimate of what would happen if what we might get should we look at a population. Now that's a point estimate, and remember that it's unlikely that the point estimate would ever really truly equal the population population proportion. So we try to find intervals, and so our next problem will be finding a confidence interval for a given population proportion. I'd like for us to look at number 13, going green. In a survey of 3,110 U.S. adults, 1,435 say they have started paying bills online in the last year. We're supposed to construct a 99% confidence interval for the population proportion and interpret the results. Well, certainly we're going to use technology to construct this confidence interval. So I'm going to move this over a little bit and let us see StatCrunch once again. Since this is a population proportion, when you go to stat, you're not going to do a z-stat or a t-stat. Those were both for finding the mean. We're going to do proportion stats because we are trying to find the confidence interval for the proportion, population proportion. It's one sample and it's with a summary. When you do a one sample proportion, with a summary, all you need to know are the number of successes over the number of observations. So it says, in a survey of 3,110 U.S. adults, 1,435 say they've started paying bills online. So the successes are the part out of the whole survey. So the 1,435 that have gone green are the ones that say they're paying bills online, and the survey, the sample size, is the number of observations. So we sampled 3,110. Now we're not doing a hypothesis test. That's chapter 7. We'll be there next chapter. We're doing a confidence interval. Now, we want it to be a 99% confidence interval, so I'm going to change my level to 0.99, and I'm going to store the output in the data table. In this case, my lower limit is 0.438, and my upper limit is 0.484. Now, so as a proportion, I can be 99% confident that the true population proportion is between 0.438 and 0.484. In my stat lab, they would probably give you a set of parentheses, and in the first box, you would do the lower limit, 438, comma, and then the upper limit, 0.484, and close the parentheses, so that your confidence interval, this is my 99% confidence interval. So once again, I am 99% confident that the true population, that's important, population proportion is between 0.438 and 0.484. Now, often they'll want you to list this as a percent. So as a percent, you might say it's between 43.8% and 48.4%. So depending on what my stat lab asks you for, if it doesn't ask you for percents, then you can just list it as a decimal value. Remember that as a proportion, it's always going to be between 0 and 1, so 0.438 and 0.434. However, as a percent, it will be between 0 and 100. So 43.8% and 48.4%. Those are the upper and lower and upper limits for the population proportion. We're 99% confident that the population proportion would be between those two values. One of the other type problems that your homework will ask you to do is to find a minimum sample size so that you could be a certain level of confidence in terms of what the population proportion would be. So we're looking at example number 18, or exercise number 18 on page 326 of your e-text. You wish to estimate with 99% confidence the population proportion of U.S. adults who think that foods containing genetically modified ingredients should be labeled. Your estimate must be accurate within 2% of the population proportion. Part A says no preliminary estimate is available. Find the minimum sample size needed. When there's no preliminary estimate available, we use 0.50 as our p-hat value. So if we go to stat, go to proportion stats, one sample, and do you see there's a power/sample size? We're trying to find the minimum sample size, so that's the command we need. We want it to be for the confidence interval width. Our confidence level was 99% or 0.99. The target proportion 0.50 because we have no preliminary, there's not been a study done where we can figure out what the estimate was. And now width, it says it has to be within 2%. That's 2% above or 2% below. So that's a total width of 4% or 0.04 for the width. So double the error that were allowed for the width. Then compute and you'll get the sample size. And it says the sample size is 4,147 adults. So if there's no preliminary estimate, the minimum sample size needed would be 4,147 adults at a 99% confidence interval. Now, let's go through this again, assuming that a prior study said that 87% of U.S. adults think that foods containing genetically modified ingredients should be labeled. So remember, we went to stat, proportion stats, because this is the population proportion, one sample, and we want power sample size. We're really trying to find a sample size for the confidence interval. Our confidence level is 0.99. We didn't change the confidence level. It's 99% confidence. The width has not changed. That's 0.04. The thing that has changed is our target proportion, because we now have evidence that say that 87% of the adults think that foods containing genetically modified ingredients should be labeled. So that would be 0.87. And when we click compute, we get 1,877. So we would need to have 1,877 participants in our study. We'd have to get valid survey results from 1,877 people. So you'd want to have more in your study, but the minimum valid number of surveys would be 1,877 to get a 99% confidence for the population proportion. So when it was 87%, we only needed 1,877. When there was no preliminary estimate available at the 50% level, we needed over 4,000. That's a much larger sample. So it's probably not a bad idea to do a preliminary study and find out what, to get a better idea of what that percent should be. So having a preliminary estimate allows you to reduce the minimum sample size. Greetings, class. I'd like to use the last couple of minutes to do exercise 21 from page 327 in your e-text. It says that there was a survey in which 1,044 adults from the U.S., 871 adults from Great Britain, 1,097 adults from France, and 1,003 adults from Spain were asked whether they consider air travel to be safe. Of those, the United States said 69% of them said that it was safe. Now, if we go to StatCrunch and we do, let me open a new table. If we go to StatCrunch and we do proportion stats, one sample with a summary, I have to have the number of successes over the number of observations. For the United States, I know that they surveyed 1,044 adults, but 69% said yes. So I've got to do a calculator and take 0.69 times 1044, and that comes out to 720.36. I'm going to round down to 720 for my number of successes. I have a confidence interval at 99, 0.99. Store this in my data table, and it says the confidence interval would be between 0.653 to 3 decimal places and 0.727. So I would be 99% confident that the true population proportion would lie between 0.653 and 0.727. So my confidence